So today we are going to see Hub and Spoke Topology deployment. We will discuss what is Hub and Spoke Topology is, what are the benefits, and how we can configure it in a lab environment. We will consider AWS as our on-prem environment, and then we will deploy this template to Azure, where we will create hub network and we will create two Spoke network, Spoke 1 and Spoke 2. In real environment, there can be number of hubs, there can be number of spokes in a company, and this architecture, Hub and Spoke architecture, is really useful in cost saving, in security, separation of concerns, and reducing the subscription costs, right? So these are the major benefits of it. You can save some costs because all the traffic, these hubs can be shared, and you don't have to create a firewall in each Spoke network or each network in your company, and VPN gateway, bastion, all those of shared workload can be shared, DNS server. There can be separation of concern, so you can deploy individual workload between certain IT teams and workload teams. So those are the 3-4 more major benefits of it, and it is really useful architecture when it comes to communication of different resources between on-prem and cloud environment, and the most used architecture. And it is really tedious also to configure also, since there are a lot of other options into the picture. And today I'm going to use this diagram to deploy my resource architecture diagram to explain the deployment. I went to save some time. I went ahead and deployed this, ran this command on my Azure environment, where it has created my complete topology, as we can see here in network voucher. When I choose my network Hub and Spoke, which I gave my resource name, here you can see we have what VNet Hub, VNet Spoke 2, VNet Spoke 1. Then we have number of resources. I went ahead and created gateway in Hub to save some time, and as well as I have created the firewall as well. So because these are the things which take some time to show during the demo, but what we are going to do, we are going to configure Azure local network gateway. We are going to configure a firewall route table on Azure side, and on AWS side, which is our on-premise network, we are going to configure a customer gateway. We are going to configure virtual network device there, as well as we are going to configure connections, site-to-site connection there. So let's go to as I have shown here, we have this whole network here, and you can see hub network. If I go to hub network, I can see this template which I was showing you has deployed these 3 important subnet. If you want to deploy a gateway, virtual network gateway, you require this subnet, a specialized subnet. So it has to be 27 from this range, as well as Azure Bastion also require a dedicated subnet. Firewall subnet also it's a dedicated subnet. So these are the important. If you want to use Azure Bastion gateway in a network, virtual network, you need to create those subnets, 3 subnets if you are going to use. These other subnets I have used for creating a virtual machine. This one I used for creating a virtual machine, and this one I was hosting a website inside my network. So but that Hub and Spoke template will give you these three subnets. And then we have some network security rules applied to these subnets. As you can see here, and I think here as well, there is no network security group. On Azure Western there is a network security group. Azure Firewall doesn't require any network security group, but on my VM subnet I haven't applied it here, but I'm using a network security group there to allow my virtual network to make connection with my hub machine. Then we have virtual machines here. We have these three virtual machines, one machine in hub, one machine in hub 1, spoke 1, one machine in spoke 2. And if you can see, this hub machine is, if you go to networking, it has network IP, private IP address of 10.0.0.4. it doesn't have any port open to internet. It allows only VNet traffic to make connection, and it is a completely locked down machine. Same applied on these machines as well. You can see all of them have private IPs. So I cannot make just to prove that those doesn't have to. This is the deployment that the template had done here. So let me go ahead and set up a network into AWS. Then we can create local network gateway, and then we can configure them accordingly. In AWS, I have already created a VPC with AWS console. So let me go to VPC here. In VPC, I have the VPC already configured. So this VPC is having this IP range, which I will copy, and this is my IP range on AWS. After creating this VPC and creating routing table and internet gateway for this VPC, you can go and create a customer gateway. So creation of VPC is really simple. You just need to same way in Azure you define the name, you define the IP range, and then you create subnets. Create VPC, create subnet here, and if you need route table, you create route table. Since for this purpose we will need route table, so I have created a route table with these two default entries here, and an internet gateway is needed here for so a VPC can communicate to external internet. So this is how in AWS you allow a VPC to communicate with internet. So you need to create internet and attach that VPC. Then for this lab we just need to focus on these three components here, where I'm going to first create a customer gateway, which is a customer gateway means you need to configure it with public IP of your VPN gateway. So here is my VPN gateway on AWS. I will copy this public IP of my VPN gateway and paste it here. Same are the steps if you are going to do it on premises. Consider this is what I am doing on prem. So on your VPN device on prem, you are going to do same thing what I am doing here on AWS. All VPN devices mostly follow same concept, where you configure public IP of your virtual network gateway with it, and then you create, and then in AWS you create a virtual network gateway, VPN gateway AWS. It's pretty fast. You have to attach your VPC with it, the VPC you are going to use for this lab. I'm going to use this one. It is attached. Then site to site VPN, you need to connection, like in AWS Azure you need connections after creating local network gateway in your VPN. Same thing here I'm going to do. And it is two tunnels, tunnel 1 and tunnel 2 connection. You are going to make AWS connection to Azure. Here I'm going to choose my network gateway, private gateway on AWS, customer gateway on AWS, and here I need to use my Azure Hub network IP range. It is 20. Spoke network, whatever network I want this virtual network, this gateway to make connection to, I need to give all of those IP address range here, so this gateway can make, this connection can make connection with these whatever request is coming from these IP ranges, it can make those requests and route traffic accordingly. Rest all I can leave as it is. AWS will take care of it. Once you are done with it, it will say this is active, and what you need to see is you need to download these configuration generic. Same is applied into your on-prem. There also you need to know the key of your VPN device and the IP. Here there are configuration for tunnel 1 and tunnel 2. We are going to create two local network gateway connecting to this for Azure. This is customer gateway. AWS side is customer gateway. So here there are two main important thing in tunnel 1. There is pre-shared key in tunnel 1. This you need to note it down, and then there is outside IP address of virtual network gateway, this one for tunnel 1. Same way there is tunnel 2 section. In tunnel 2 section you need to note down this, and you need to note down outside IP address of this. So first thing, we need to copy outside IP address of tunnel 1, since we are going to configure tunnel 1 now. So here I will copy this. I will go to Azure. I will create local network gateway on Azure, LGW tunnel 1 to AWS. IP address of that what we copied from this file. Then range of your virtual network on AWS. So that was here. That will be your on-prem range. If you are doing for on-prem network, you have to add all of address space you have into your on-prem network, and you can choose the same hub spoke, same location. Rest you can leave it. So this is local network gateway for tunnel 1. I can do that for tunnel 2 to AWS. And in case of tunnel 2, I need to copy tunnel 2 outside IP address virtual network gateway. So this is that, and then same IP address, since we don't have any other network here. So I can, when I delete them, I delete everything. So it will take some time to create this gateway, local network gateway. After the local network gateway is completed, I can again go to my virtual network gateway on Azure. Here I'm going to make connection to AWS on tunnel 1 connection. VNet to VNet gateway is when you want to make connection between different VNets on Azure. Right now we are going to do site-to-site VPN since it is between sites on-prem and on-site and cloud. In our case, on-prem is AWS. Then for tunnel 1 I need this key. For tunnel 1 pre-shared key is this here, and I will leave everything else as it is. This connection will take some time. As you can see, it's already updating. I will make one more connection for tunnel 2 AWS. I will choose tunnel 2 to site with tunnel 2. Now I need to copy tunnel 2 pre-shared key. Make sure you copy properly, otherwise there won't be any connection. I leave everything as it is. In some time we will be able to see here, instead of a status updating, it will be connected for both of these connections. And in AWS as well, if you go here in AWS site-to-site VPN connection, you will be able to internal detail this. Right now it is down, but once connection is up, it should say here up for both tunnels. Let's wait for some time. It might take up to 10 minutes. Yeah, you can see it didn't take 10 minutes. You can see tunnel 2, it made connection. In AWS also, you can refresh it. Tunnel 2 should be up and tunnel 1 is also up. So here also both are connected. That means we are able to communicate from AWS to Azure, and we can verify that from. So I have already created a machine in AWS. This is my machine. Here I have logged into this machine here, and in this machine my hub network. Let's see hub network. Hub machine is this. So here I'm going to see if my AWS network is able to call. I think it's still. I just noticed I might have missed my entries for my hub and spoke network on AWS routing table. Let's go to AWS and make those entries. I'm in AWS, and in routing table section I need to select my routing table for my VPC which I have attached gateway. Here you need to make 3 entries, one for spoke 1, spoke 2 and your hub network. First I'm making entry for my hub network, which is 10.0.0.0. I will attach target, it will be gateway, it's AWS gateway, remember. I will save these changes. I will repeat same thing for both rest of my network on AWS. Azure. This is my Spoke one. I will set target for as a AWS gateway. See, I will do same entry for Spoke 2, which is 10.200.0.016. I will attach VPN gateway with this. So after this changes, my AWS machine should be able to communicate with my hub as well as Spoke network 1. Since we have peering there only for Spoke network 1, we don't have any peering for Spoke 2 yet. We are going to make that peering soon. So as you can see, my AWS machine is able to communicate with my hub network. Now I will go to Azure and check my hub network, where we have just one peering from hub to Spoke 1. So since we have this peering, my hub should be able to speak to Spoke 1 and Spoke 1 should be able to speak to my hub. But as you can see, we don't have any peering for Spoke 2. Let's make that peering and do replicate same thing what we have done for Spoke 1. We will create peering from Spoke 2 to hub and hub to Spoke 2 from same UI. In this peering screen, we will choose, it will create two peering, one from hub to Spoke 2 and one from Spoke 2 to hub. We will choose this option where traffic should flow between virtual network and any remote traffic from other virtual network. This setting is important here because this is gateway. Since we have gateway attached to this hub network, we want traffic flow from our hub network to our on-prem network to pass through from this gateway. So we have to choose this option here for both of these peering from this screen, and we will choose our subscription. Then we will choose the network we want to do peering with from this network, hub network, which is Spoke 2. After this peering is done and successful, our hub should be able to speak to Spoke 1 and Spoke 2, as well as all of my spokes should be able to communicate with AWS machine over the private network. Let's go to AWS machine. We will try to ping machines now. See, this is my AWS machine IP address. I will ping my hub from here, which is 10.0.0.4. So as you can see, we are able to communicate with our hub network from on-prem network, which is similar to AWS. We will see if we are able to communicate with the Spoke from here. As you can see, excellent. And then, so right now we have connection from our on-prem network to hub and spokes to on-prem network and hub. But since this is happening because of this setting, the reason we are able to communicate from our on-prem network to hub Spoke network is because of this. Traffic is passing through our gateway, but what we don't have is connection between our spokes. In our case, there is only two spokes, what we can do is we can put peering connection between spoke 1 and spoke 2, but that is not always recommended. If in some architecture of hub and spoke topology there can be n number of spokes, and it's not recommended to put to create so many peering, because Microsoft, it's not good for design security, as well as there is a charge for each peering connection when traffic travels through peering connection. So in this kind of scenario, it's always recommended to set up an NVA, either using Firewall or either using a virtual machine, where you can, in your hub, where you can set up a router on virtual machine, and then you can set up a route table. But there is no connection between spokes, so we can verify that. If I go here, I am in my spoke 1, it's my spoke 1. As you can see, there is no connection from here, from spoke 1 to spoke 2 and vice versa. So to avoid that, are the options we have. We can have, as in this architecture you have seen that we can set up a Azure firewall or VPNs. So what we can do, we can set up route table to traverse all of our traffic which is going from any spoke. We can route it to this firewall, and from firewall in a hub we can route that traffic to any spoke. And why this is necessary, we could have done peering between these virtual network on Azure, spoke 1 and spoke 2. That is fine if you have 1 or 2 spokes, and it's not always recommended for security as well. But in scenario like this, in this scenario, like where you have hundreds of spokes, right, there you won't be doing peering between that many spokes. There are scenarios like that, and number of spokes in some scenarios. So for that, it is always, and peering, it has some cost, right? When there is a traffic flowing through this peering, there is a cost Microsoft is charging for you. So you cannot set up that many number of peering if you have a lot of spokes in the spoke network. So for that, what you can do, you have to this. So in this scenario where a spoke should communicate with other spoke, we have seen that my spokes which I have set up are not able to make connection. Spoke 1 is not able to talk to spoke 2, and spoke 2 is not able to talk to spoke 1. For that, you need to set up a firewall as a network virtual appliance, or you can have a virtual machine also set up into hub and have NVA router installed in it and enable routing on it. That also should do the same thing, but firewall gives you more control over your traffic. You can write your own rule, network rule, or on website you can write certain rules, and through which you can control your traffic more securely. Application rule as well. So it's always recommended to use a firewall on that, and through this firewall, I as you can see, I have added one rule here where I'm defining if there is a traffic from spoke 2, it should go to spoke 1. Okay, and one more network rule I have to define, which should, for spoke 2, spoke 1 to 201. Okay, rule 2, TCP 10.100.0.016 to 10.200. So there are two rules and star for all ports. And so one way it's from 100 to 200, from spoke 1 to spoke 2, and one from two rules, one from spoke 2 to spoke 1. So that rule, so once this is there, this rule is there, then you need to go for routing, creating of routing tables. That template we created, it gives you routing table. If it doesn't, you can create two routing table, one for spoke 1, one for spoke 2. In routing table you have to attach subnet. So for this one I have a subnet attached for spoke 2. In this one I have subnet attached for spoke 1. So apart from subnet, you need to define route. So if in this scenario, if I choose this one, I need to define a route if traffic comes from for spoke 1, and if it comes from this route 16, this range, from this range it should go to our network virtual appliance, which is 10.0.3. This is our firewall IP address. Let me make sure that is our firewall IP address. 3.4 table. Oh, I configured this rule to 10.0.16. You have to wait spoke 1 virtual appliance 10.100.0.016. Yeah, and now one opposite rule there. Here spoke 2 to 1 to 1. Now 10.200.0.016 virtual appliance, our firewall IP address. Now our spoke should be able to, after this rule gets applied, our spoke should be able to communicate through firewall from spoke 1 to 2 and spoke 2 to 1. We can first verify that on Network Watcher. It is a really great tool to check your topology, your flow, verify, and where your how your IP address, what next hop it is going to. So if I do spoke 1 to spoke 2, spoke 1 to spoke 2, it will tell me it is going to firewall, because we have set up that routing table. So any traffic from this will go to firewall, and from firewall, based upon our network routing, it will go to this destination. It is taking some time. Let's go to our machine, and from there we can check. As you can see here, we are able to communicate with from spoke 1, we are able to communicate to spoke 2, which we were not able to earlier. So that concludes that we are able to communicate from on-prem network to spoke network as well as hub network. We are able to communicate from between spoke to spoke. We are able to communicate from any spoke to hub as well. That concludes this demo. Hope you really liked it. Thank you so much.